To study how mathematical thinking develops, the research team began by asking, how might children solve problems that use mathematical ideas before the procedures to solve them were formally introduced in school? The researchers introduced the problem, shirts and pants. Stephen has a white shirt, a blue shirt, and a yellow shirt. He has a pair of blue jeans and a pair of white jeans. How many different outfits can he make? Stephen has a white shirt, a blue shirt, and a yellow shirt. He has a pair of blue jeans and a pair of white jeans. How many different outfits can he make?
W for white.
The students spontaneously began to make drawings.
Okay, blue, and then yellow shirt. He has a pair of blue jeans and a pair of white jeans. How many different outfits can he make? Well, he can only make two outfits. Well, no. How many different outfits? He can make a lot of different outfits. Look, he can make white and white. He can make all three of these shirts with an outfit. Yeah, but you can make it different ways too. Just like you can make white and white, so that's one, by doing W and W. Two could be blue jeans and white and a white shirt. Yeah, we'll just put white. Okay, yellow shirt and number three could be a yellow shirt. It can't. But yellow shirt can't go with the white. Little white to go. Yellow white shirt. No, how many outfits can it make? It doesn't matter if it doesn't match, as long as it can make outfits. You can do 5 combinations. You can do number 1, white and white. Number 2, blue and white. Number 3, yellow and white. Number 4, blue and blue. Number 5, yellow and red.
Let's look at this segment again and see what the researchers found out about each of the students' thinking.
And then yellow shirt.
Very early in the tape, Dana drew lines to show combinations.
He has a pair of shirts with an outfit.
At that time, the school's curriculum did not include teaching multiplication in the 2nd grade. But Dana's approach to the problem shows that she is capable of the kind of mathematical thinking that underlies multiplication. Dana's initial graph shows 3 shirts, with all but one, the yellow shirt, connected to 2 pairs of jeans. At this point, Dana was influenced by her sense of fashion.
A yellow shirt. It can't. But yellow shirt can't go with the white. Little white to go. Yellow white shirt. No, how many outfits can it make? It doesn't matter if it doesn't match, as long as it can make outfits.
She believed that yellow and white don't go together.
It have to go with each other, Dana. What outfits it could be.
As teachers, how often have we seen cases like this, where students come up with a logic that makes sense to them, but is completely different from what we expected? Stephanie made drawings and wrote letters and numbers to keep track of her random attempts to find outfits. Using these representations, she found 5 outfits. Notice that Stephanie, on her 5th combination, first wrote W over the B, then wrote a Y. Does this notation stand for 1 or 2 outfits? For Michael, perhaps his sense of style required that outfits have matching colors. He created a new color of pants, yellow, that wasn't included in the problem. The researchers were wondering, how were these students influenced by each other's ideas?
What was fascinating was that nobody seemed to be truly bothered by the fact that they had come up with different numerical answers to the question. to me, that was very important because it really did say you do need to give children time to build, just to build and to think. That's what that session was for. That was the purpose. So we really kind of left it open.
Is that all the ways you can make it?
Yeah, that's the only way
sure.
you can make it.
Let's see.
They kept on hurting noises. When they
The first opportunity to revisit the problem came 4.5 months later, when the students were in 3rd grade. In the meantime, the students' classroom teachers, who cooperated with the study, were careful not to tell the students how to solve the problem. The wording of the problem was identical. Let's see how their thinking has grown.
Want me to read it out loud?
No,
Here's a pair of blue jeans, a pair of white jeans. How many different outfits can he make? Well, why don't we draw a picture of that? Okay. He has a white shirt, a blue shirt, and a yellow shirt. Okay. He has let me read it. He has a blue jeans and a pair of white jeans. Okay, so let's make jeans.
First, the students made drawings and used letters to show the colors.
All right, now let's find out how many different outfits you can make. Well, you can make white and white, so that would be one.
When they started counting the outfits, it was Stephanie, not Dana, who started drawing lines to connect the different shirts and pants, and both of them solved the problem this way.
Now we have two. I have 6 so far. I've got 1, 2, 3, 4, 5. What are your other combinations? I have white and blue. I've got white and white. I've got blue and white. I've got yellow and white. What were your 2 other combinations?
I have 6.
So what were your 2 other combinations?
Only one other combination.
I only
The yellow
have 4.
and the blue.
Yellow and the blue. And then what
And
was
the
your
yellow and the white.
I put the yellow and the white.
Alright, then the
1, 2,
blue
3,
and the white.
5, 6. Oh, okay. So I have 6 too. Please 5 in there. I have 6. Okay, what is it? It's 6.
Are you both convinced of that?
Yes.
Can you explain it to me?
Well, okay. If we have 3 shirts and 2 pants, we just drew lines and they could all make combinations. And they all make combinations. And that is like 6. We made white and blue. Yeah, white and blue. We made blue and white. We made yellow, blue, and yellow, white. That's 6.
Is that 6?
Yes.
Okay, you sure that? What are these lines that you drew?
Well,
you drew lines between the shirts and pants.
So that we could make sure that we were, so instead of we didn't do that again and say, oh, that would be 7, 8, 9, 10, we just drew lines, so then we could count our lines and say, oh, we can't do that again, we can't do that again.
Oh, that's very nice. And you're sure that there were 6?
Yeah.
Michael solved the problem with lines too, but he didn't make drawings. Rather, he drew lines between the words. This is interesting because last time, when he came up with a completely different answer, it wasn't clear whether Michael was hearing or noticing the solutions of his partners.
Say a strategy that one child had come up with in 2nd grade. In 3rd grade, another child had modified that strategy and was making use of it, which goes to show that, really that first session was just so important for getting them to build strategies and to modify.